Okay, Year 9, what I'd like to do is just run through some of the expected knowledge before we start linear equations. So I'll have a go at a few of these. I'll probably do them all and we'll see how we go. Hey? So we've got for exercise 3A, oh yes, this is a review of just solving for an unknown. So what we need to know for exercise 3A is what question 1, 2, 3 and 4. So let's just have a quick review of that. So we have 7x equals 42. Now we just need to find the unknown, which is x, and to isolate x, what I'm going to do is just divide both sides by 7. Okay, so I can just say therefore x equals, well, 6 7s are 42, so therefore x equals 6. Okay, 1b, x minus 15 equals 8. So what we need to do is just isolate that plus 8. So this is, well, we need to move on to the other side of the equation. So what we're going to do is just, when we move that to the other side of the equation, remember that minus 15 turns into a plus 15. So we just rewrite it like this. X equals 8 plus 15. 8 and 15 equals 23. Okay, C, x plus 9 equals 26. So remember, we just want to do the inverse of that. So the opposite of plus 9 is minus 9. So x equals 26 minus 9. Okay, 26 minus 10 is 16, so that makes that 17. Okay, and D, x over 3 equals 12. So the opposite of divided by 3 is going to be multiplied by 3. So when we move that to the other side of the brackets, the equal sign, it's just going to look like this. X equals 12 times 3. That looks like x should equal 36 then. Okay, copy and complete this flow chart to build the required expression. So this takes you back a little bit, doesn't it? It's been a little while since I've looked at these. So when we say x times 5, we just want to say, well, that's 5x. And then we add a plus 4, well, that's 5x plus 4. So that's building expressions. Now, what must we do, 2x, to get it to say minus 2? What do? We say minus 2 there to be x minus 2, and then we divide it by 3 over here to say x minus 2 divided by 3. Now, write each expression in expanded form without brackets. Oh, we've been doing a little bit of this recently, haven't we? So we've got question 3a. So 3x plus 5, so remember this is the distributive law. So we've got that in our factorized form, so 3 times x equals 3x, and plus 3 times 5 is 15. Now let's have a look at 3b. Okay, negative 5, oh, okay, negative 5, 2x minus 1. Well, negative 5 times 2x, well, that's got to equal negative 10, and then an x. Remember, we do the coefficients. Now we've got a negative times a negative, so that's a positive, and negative 5, and then it's just 5 times 1, so negative 10x plus 5. Okay, let's simplify each of these expressions. So this is where we collect like terms. So question 4, 4x, I'm just going to rewrite it, collecting like terms as I go, and that's acceptable for you. Plus 1, it's meant to be a 1, and then I go, well, 4x plus 7x equals 11x plus 1, and that's simplified. So B, let's collect our like terms. What you might want to do is just get a highlighter and just highlight the like terms, and note that those are the different types of terms in this expression here. So we've got 5x, take 3x, take 9 plus 2. Okay, well 5x take 3x, well that's got to be 2x. Now negative 9 plus 2 is got to be negative 7. Okay, the next one is to plot the points on a Cartesian plane, shown in here. So let's go this, negative 2, negative 1. So remember that's our x value. So I've got to read from the x value, but I've got to go down to negative 1. So that's got to be that point there. Then I've got negative 1 and 0. Negative 1 on the x-axis is there, and 0 on the y-axis is there. Then I've got 0 on the x-axis, so that's got to be this line. And then 1 on the y-axis, so it's there. Then I've got a 1 and a 2, so 1 on the x-axis up to 2 on the y-axis, and then 2 and a 3, and you can see that that's a straight line. And that'll be important because we're going to be trying to turn our expressions into lines on a graph over the next couple of chapters. Okay, I'll do a few of these. Okay, so follow these instructions to find the position of a point and write the coordinates of the point. So what we're going to do is, number 1, we're going to start at 2 on the x-axis, so it's that, and then it's that. So 2, 1. So we're starting here, and then we're moving 3 units right. 1, 2, 3. So we've gone that far to the right, and then 4 units up. 1, 2, 3, 4. So we've gone up to there. So let's write our units here. So that's 2, 1, and our new value is 5. What did I do there? No, I think that's all right. Okay, so we've got 5, 5. So 5, 5. Okay, let's try a different colour so we don't get too confused. Okay, start at negative 4 on the x-axis, so that's this one here, and then 3 on the y-axis, so that's got to be here, and then move 2 units to the right, and then 5 units down. 1, 2, 3, 4, 5. So this is over here, negative 4, 3, and so this has got to be negative 2, and where are we going? Negative 3. Okay, let's try a different colour. Start at 0 on the x-axis and 4 on the y-axis. I'll turn off that, go away. So where were we? We've got 0 and 4, so that's there. And we're moving 1 unit to the right, and then 3 units up. So 1, 2, 3. 3 units up here. So this now becomes 1, 6. Now find the number that is halfway between each pair of numbers. Well, all we do is we just say 3 plus 7 over 2. Well, that's got to be 10, so that's got to be 5. Negative 4 plus 8 over 2. Okay, negative 4 and 8 is got to be 4. 4 over 2 is got to be 2. Now 6 plus 9 over 2. So that's 15. 15 divided by 2, that's got to be 7.5. Now that's the same thing as the average for each number. So halfway between 5 and 11, so 11 plus 5. Now the number of the numbers is, we've got 2 numbers, so 16 divided by 2 is 8. Negative 6 plus 2 over 2, well that's negative 4 over 2, that's got to be negative 2. Okay, 4 plus 7 over 2 is 11. 11 divided by 2, that's 5.5. Now calculate each of these correct to 2 decimal places where appropriate. So this is where you use your calculator. So let's just do that. And oh, that's a bit of a pain. I'll have to, let's see if we can do it with this calculator here. 17 squared, 289. And 13 squared plus 21 squared, well, we'll just go 13 squared. Where's my x squared button? Plus 21 squared. That's got to be 610. I'm losing my calculator, which is a bit of a pain. There it is. The square root of, where are we? 275. So we go square root, oh, maybe I need to cancel that. Let's see how this goes. Square root of 275 equals, maybe I need to do that first. Okay, yeah. So 16.58. I think it's into 2 decimal places. And that's it.